Okay, let's get started. Welcome everyone at the session called Benefits of Eclipse Che when developing multi-container microservices application. My name is Eugene, and I'm with Red Hat Developer Tools, the team focusing on Eclipse Che and developer experience. Today's presentation will cover a short introduction of Eclipse Che. There have been quite a few sessions at this year's EclipseCon related to Che and Thea IDE, which is good. We'll look at a few cloud-native development challenges and actually the solutions that Eclipse Che offers to solve them. And there will be a short demo showing deployment of a microservices application to Kubernetes cluster and actually developing this app in Che, fixing some bug using the same YAML definition and updating deployments in the Kubernetes cluster if my Jenkins pod is up having some issues due to network. All right, what is Eclipse Che? Eclipse Che is a Workspace server and a cloud IDE. It's an Eclipse Foundation project. It has been an Eclipse Foundation project since 2016. Since then, the project has gained over 4.5K stars on GitHub, if that matters. It has seen over 100 releases. There are almost 100 contributors. Some of those are Red Hat, SAP, Software AG, and Codenvy, the company that stood at the roots of Eclipse Che project. And Eclipse Che has been forked more than 800 times. As a Workspace server, Eclipse Che supports Docker, Kubernetes, and OpenShift. And by saying it supports a particular infrastructure, it means that Eclipse Che both runs on those infrastructures and uses them to create cloud workspaces, using the underlying APIs to create and manage cloud workspaces. And a cloud IDE is what it is. It's an IDE in your browser that offers you a web editor, project tree, all of the possible language smarts, debugger, and plugins. Currently, GWT, the legacy one that has been with the project since the very beginning, is offered, and a TypeScript IDE, Eclipse Thea, which has been chosen as the default IDE for Che 7. So what are the typical problems that Eclipse Che is trying to address and solve? I think this is the most common phrase when two people working on the same project but use it in different environments, say, it works on my machine. It always does. I mean, if it doesn't work on my machine, then probably I'm doing a poor job as a software developer. It has to work on my machine. But if I give you some project and odds are that half of you will fail to run it with the existing README and requirements just because of a minor difference in, I don't know, OpenJDK or Maven version or some other things. So yeah, it works in my machine doesn't mean it works. It should work everywhere, and Eclipse Che is trying to address that problem by creating a workspace that is replicable and easily shareable. So if it works in your Che workspace, it works in every Che workspace. If it doesn't, then your original Che workspace is messed up. And next thing is that we see this switch from the monolithic apps to microservices. It had just started, but the enterprises tend to realize that splitting monolithic application to microservices and deliver them to your production, to your customers as containers is a better way to go. And but developing microservices locally is quite a challenge because it's difficult to have the same environment that these microservices will use when they're running out there in the cloud. So the second problem that Eclipse Che is trying to solve is development of microservices application using the same environment they will run in. So the problem is, what we love containers for? Once you define a deployment and the image or the images in there, you're pretty sure that it runs the same way on any cluster. As long as you have a healthy Kubernetes cluster, things should be okay. So these deployments are well defined and they are predictable. Localhost development turns all of us into localhost ninjas, right? So to start working on a project, you need project files, you need your IDE, of course, you need build and runtime environment, and you may need some extra tools, a database, maybe, I don't know, a router, HA proxy running and doing something for your web server. So localhost environment never replicates prod environments. So something that works on localhost may or will certainly fail in a containerized production or staging environment. So the solution that Eclipse Che offers is that simple. What you need to do is to grab your definition of your application runtime, your Kubernetes YAML, and give it to Che and say, hey, Che, can you create a workspace for me? This is what my application needs to run, and this is the tooling I need. Say I've got a Java and Golang project with 2 technologies in one project. This is my runtime application definition, and this is the tooling that I need in the IDE, and these are the sources. So Eclipse Che will start this environment and add tooling on top of it, add extra services, and add your source code in the IDE. So with a single mouse click, you will have the entire environment that replicates as much as possible your production environment. So how it works, as already said, in the center we put your application runtime definition in the center. Then you will have an IDE delivered as a web IDE in a container, in a sidecar. We'll add some tooling containers. For example, we may start a language server for you to do analysis of your Java code. And you may add build containers. For example, if you want to decouple build and runtime, you may perform your Maven or Gradle build in one container and use the resulted artifacts in your runtime container, identical to the one that will run in your production or your customers will run. All these containers share volumes, so they have access to the source code. They use services, Kubernetes services, to communicate with each other when necessary. As said above, you can separate build and run, and you can attach a remote debugger from the IDE into any of the runtime or build containers where your app is running in a debug mode, listening on a socket. Workspace environment, it consists of containers. It can be one single pod with one container, or one pod with multiple containers, or it can be multiple pods. Whatever makes sense for your particular project, for your application. If it's not okay to put all of the services into one pod, for example, there may be some port overlap, or you don't want them to share the same pod network, it can be different pods. It's defined by a Kubernetes YAML. It can be defined by a Docker image or a compose file, but J7 focuses mainly on Kubernetes. Shared volumes to exchange source code between them, and you can use artifacts across all containers. And it's possible to expose services. For example, if you need a preview URL to your web application, or you need external URL for other services to contact your web app, we'll publish ports for you, or when on OpenShift, we'll create an OpenShift route, or when on vanilla Kubernetes, it will be an ingress, Kubernetes ingress. The IDE, so it's fast JavaScript IDE, client-server architecture. We introduced the concept of pluggability in Eclipse Thea. So you can add runtime plugins without the need to rebuild or even restart the IDE. This makes it possible to use a custom IDE per workspace. Say, as a Golang developer, you don't need Java tooling, but you need a Golang plugin and a debugger. As a JavaScript developer, you need a whole different stack, and your IDE will look differently since it will pull the necessary plugins. And you can use different IDEs as well. So you can use Thea, or you can use GWT IDE that is bundled with Che, or there may be some other web IDEs, or will be other web-based IDEs there, so you can define them as your IDE and launch as part of Che Workspace. Tooling. Just opening your code in a web-based editor, yeah, it's not something that a developer will expect in the year of 2018. You expect to have all of the language smarts, all of the code assistance, code navigation, refactoring in your web-based IDE, and that is powered by the language servers. So Thea IDE supports and implements language server protocol, which means language servers for almost all modern popular languages are supported. Language servers can start in a local mode as a processes, and the client communicates with them as such, or you can run your language server, a custom one, as a sidecar and make it listen on host port, and Thea from one container will talk to a language server via host port in another container. So this way you can register new language servers. And of course, debugger is supported as well. It's not yet part of Thea, Java debugger. There is no JS debugger already, but the debugger protocol has been implemented, which means that all of the implementations of debuggers for other languages that exist out there can be easily plugged in. And build containers. There is this concept that it's better to decouple and separate build and runtime. And by defining build containers, it's possible to use builder image identical to the one that your particular CI uses. Because it often happens that Maven build succeeds on your local machine, but it fails out there in the cloud on CI because of a minor Maven version difference, or it uses some custom settings.xml with private repos and some custom settings. With build containers, you can replicate the build environment. Build containers share volumes with other pods, so you can easily build artifacts, and other containers will consume those artifacts. And you can allocate RAM per container. Different projects require different amount of RAM, so whatever makes sense for a project, 2-3 gigs for a heavy Maven build, it's you who control it. So in a nutshell, the way that you can convert your cloud workspace, your application Kubernetes runtime into a Che workspace is you grab the recipe, you create an Eclipse Che workspace from it. You then have fun with the IDE, you debug, you break things, you fix things, do things that you enjoy doing daily as a developer. And then you can either use Git to push to a remote repo, and that will trigger some build pipeline, or you can interact with the Kubernetes or OpenShift API directly from the IDE. Kubernetes and OpenShift plugin for Thea is in works, not yet available, but this is something that is coming. Okay, demo time. I will quickly show deployment of a microservice application on Minishift. We'll create a workspace. I have already created a workspace for that in Eclipse Che. will push to GitHub, and that will trigger a CI job, but that part won't work. My Jenkins pod didn't start because of some network issues. So we'll spend more time in Che then. Okay, so the application that I have chosen is a simple microservices app that consists of 4 components. There are some backend APIs, and there is a front end. So this is a to-do web application to keep track of your to-dos. And this is how this application looks like when deployed on, this is OpenShift origin. It will look almost the same on Kubernetes. So you can see that each microservice lives in its own pod, and pods communicate with each other using Kubernetes services. Okay, and if I go here, I will log in. And something went wrong. Please try again later. That should have happened. If I go to issues, I see that some guy has created an issue for me. It was me, and he even placed this button. Please fix this, and this is the actual environment that you will need to do that. Hopefully that will work. So we call this magic button a factory, an Eclipse Che factory. That link contains an ID that is saved in Che database. I have created this factory a bit well before the presentation. And that ID contains configuration of my workspace that I need to start developing this microservices application. So it will start an IDE for me. It will clone the project. Never mind the error. It should be fine. It should clone it, and I should be able to start using the project, start building it, debugging, and actually fixing the bug that I have there. Okay. Not cloning. We can do it manually. Probably didn't like something about network. Wow, that's slow. While it's being cloned, one more time, let's take a look at the architecture. So I'm getting there at the front end, not being able to log in. So obviously, I will want to take a look at Authentication API and what's going on there. And to do it locally, I kind of need to run the entire infrastructure and somehow well, attach my IDE to it and to be able to figure out what's going on there. It's cloning something big. Whoa. Not sure why that happens. Let's do it again. Okay. There's nothing heavy in it. Okay, let's wait for a while we give it a chance to clone. The Eclipse Che itself is running as a pod, so you can see the namespace where Che is deployed, and it's a container with a web server running in it. And when I start a workspace, it actually starts a pod which is the exact same replica of the environment I have in my production environment that is broken. So you can see it references multiple containers, all of my APIs and services in there. And you can see that there is a Thea image, which is my IDE. There is machine exec, which is the backend for Thea plugin that lets me open a terminal into other containers and run exec commands in there. So the Workspace agent the Workspace server has created the identical copy of my environment, but git clone doesn't work for me, which is not good. Okay, we're lucky. All right, that's much better. Now I have my source code, I have my IDE, I have exact same environment that is not working in my production, and let's fix some things. There is a task extension in Thea that makes it possible to run commands in those containers. So what I will do now, I will run a command in my front-end container that will stop the service and rerun it. I haven't made any changes yet, but let's see if something that is not working in production isn't working here as well. So who knows, maybe it works in a Che workspace. Admin, and it's the same error. All right, so the front end calls Authentication API, and here is this module with, it's a Golang server. Let's go to main Go. You can see that I've got language smarts for Go language, since I knew that for this particular project, I need Java, Golang, and Node.js. So these are the languages used for those components. And I can see that there is a user API address, so this microservice calls another microservice, and it gets the URL from environment variable, and there is a user service, so you can see I can navigate through code using Golang plugin in Che and Thea. And well, it actually makes an HTTP request to user API address. Let's run auth API update. Let's run it to follow some logs. So we're recompiling Golang binary. We haven't made any changes there yet. And let's give it a go again. We have some logs in here. Okay. And it actually says that when it's calling users API, it's 404. So something's wrong with another microservice, which is users API. Let's go ahead and open that module. We can see src main Java, so it's a Java microservice. It's actually a Spring Boot application. And you can see here that the language server is starting for Java. So I will have all of the language smarts, code completion, navigation, and all of the stuff that language server protocol implements, I will have in my workspace. So you can, it has already started, and I can have things like code completion, code navigation. So, and this class is actually the REST method. It's a path param username, and it returns a user and gives it back to Authentication API. So you can see I've made a very stupid mistake of changing the endpoint. It's not users as the Authentication API calls it, but it's user. So someone must have changed it and ran tests locally. I don't know, but that's not good. Let's fix that. And now I need to compile my application and rerun the service. You have seen that I've been using commands to run, but I can as well use I have this extension that lets me SSH, gives me a shell to all containers of my environment. This is my environment. It's different from the one that runs in production. I can mess it, I can break it, fix it, so it's mine. And I have a terminal in there, and I can run Maven command to compile it and to see if it has fixed my microservice. All right, so build success, and well, now I will run the command to update users API. And when running a command, I choose a command that is part of the workspace definition, and then I choose a target to execute that command into. So, and since I know that my Spring Boot application runs in a container called Microservices Users API, I will do that. So I'm stopping the server, the Spring Boot server there, and restarting it, and it uses the new compiled binary. And I've told you the thing about build containers, and I've ran that MVN clean package in a separate special build container with particular Maven version in there in Java. And the artifact is immediately available in all of the containers, so I can grab it from whatever container. It makes sense. All right, so you can see that now I seem to know what's going on. Let's go to Auth API logs and see if it, yeah, so I've got 200, which is fine. I can open this this route in a new tab. So similarly, I can do whatever I want with any of the components. For example, add to do, and I can do like this, and well, my server, I can run my server in a watch mode, and you know, it compiles automatically when picking up file changes. And well, this way I can play with any of the microservices components without the fear that I will do something bad to my production environment. And at the same time, I can be sure that this environment is the exactly same replica of what's running up there. The end of the demo was supposed to be pushing changes to GitHub, and that will trigger a Jenkins job that will rebuild the images and update my production environment with a fix. However, my Jenkins had problems with installing some of the plugins, probably network. But yeah, Git is here. You can you can create a branch or create a pull request, and that may trigger a CI job, and that CI job will update some staging server, and others are able to verify your fix. Or you can create what we call a factory, and a factory can reference source code. If we take a look at the factory definition, this is the recipe, the YAML in a string, and you can see that here the factory references Git URL, but here in parameters you can specify branch or commit ID. So I can create a factory with my fix without pushing it to production yet, and whoever has this link can create the workspace with my fix and be able to verify that it's okay even before you merge it to master, or even before create a pull request, because you can specify commit ID in here. So this concept is called Codenvy Eclipse Che factories, and all of the Che master services are exposed as REST APIs, so you can embed these things into your CI, into other systems in your infrastructure, like I did with this button on GitHub. All right, so here are some links on where to get more information about the project. And this is where you can actually try Eclipse Che running on OpenShift. It's che.openshift.io. It's free to use. Up to the workspace is up to 3 gigabytes. You can use it for whatever purposes you need. Okay, thank you. And if you have any questions, you're welcome. All right, then. Thanks for yep.
Something from a desktop IDE that's important to me is incremental compilation, and I seem to be losing that.
Can you?
Your regular Eclipse IDE. As soon as I save the file, it compiles it for me.
The incremental builds. Well, you've seen something similar for the NPM. I've changed the source code, and it updated the web page with it. I'm not sure that JDTLS plugin would do that for you. So incremental builds are not yet there, but yeah, that's definitely an interesting concept. Doing the same in the cloud, pre-compiling while you're editing. But no, you will not have that in yeah.
It really depends on the configuration of the project. Some projects suggest
yeah, what the language server will do for you, it will do all of the dependency management. So if you add a dependency, you'll have it in a class path and in your code smarts, but no background compilation and incremental builds. Okay, thanks everybody for attending.